Are you aspiring to ace the UPSC CSE? Commence your transformational journey with the Vision IAS Delhi GS Foundation Course 2025. Empower your exam preparation through cutting-edge educational technology and personalized learning experiences with tech-enabled learning. Dive into concepts with animations, videos, and interactive tools designed for maximum understanding and retention. Personalized student portal. Access live classes, recorded sessions, and extensive academic resources, all at your fingertips, anytime, anywhere. Enroll now and step closer to accomplishing your IAS dream. With the Vision IAS Delhi GS Foundation Course 2025, batches starting from 31st August, 5 p.m., 17th September, 9 a.m., 24th September, 1 p.m., 30th September, 5 p.m.
Let's continue the next topic. The Indian Semiconductor Mission. So it's this clamor about semiconductors. What is so special about semiconductors? And why now the semiconductors have become highly critical? Manufacturing chips, why? अभी तक क्या हो रहा था? Till now, there were chips being manufactured. So the science and tech part, okay, current flow करता है. Then the name says semiconductor, so you have an integrated. What happens here? This is mostly of or germanium. So how does this material conduct? What is the speciality about this silicon? Silicon Valley or this? What is the speciality? नहीं वो तो याद किया ना P type N type. P type N type बनते कैसे? So first, how does it conduct electricity? It's a semiconductor. You can control the current here. How do you control the current? First, you add certain other materials. Doping that happens, this is semiconductor, and then you control that current through addition of, right? Now this chip, which you could control the amount of current that flows, that means the processing, storage, so many functions you can do in number of devices. These semiconductors, or something called as integrated chips, these were integrated circuits. These were useful mostly for military and space applications. 1950s, 60s, 70s, mostly military and space applications. Japan revolutionized the use of these chips from military and space to commercial applications. So whatever smart devices you have, all of them are being controlled through semiconductors. The very simple function of the window up and down through a button, that in cars is also controlled through a semiconductor. So a lot of commercial applications, and now since the technology has improved further, all of it works on semiconductors. This is the basics of the semiconductors. But why has this thing turned out to be very critical in the last few years, especially the last 5 to 10 years? The speed of change has increased, especially after COVID. What's so special about these semiconductor chips? We're moving towards sustainability. So, electric vehicles, so the technology would be required. So what has happened right now specifically in the semiconductor domain? So what you are trying to say is absolutely correct, that the commercial uses of semiconductor have increased multiple times because all of the latest technology that is coming in is happening through semiconductors. So you need control, because if you need any control over the technology, you need to have certain control over the manufacturing of chips or designing of chips, number of things within the semiconductor supply chain. Because most of the technology, artificial intelligence, to anything right now will have the use of semiconductors. In fact, if you see, Nvidia recently has beaten Google, third most valuable company by market capitalization. Now, this is a significant achievement for a company which manufactures only one particular type of chips, that is the graphical processor units. The GPUs which are manufactured by Nvidia, they're mostly used for parallel processing. Because the traditional chips are not good at parallel processing, those GPUs have made Nvidia the third largest company, most valuable company by market cap. Nvidia has grown like anything in the last 5 to 10 years. Artificial intelligence, Nvidia has a very big role to play now. In fact, the latest development, the x86 chip, that also was a conflict between US and China. US stopped the export of that chip to China. China does not have the capacity to manufacture those as of now. The technology is based on, the technology is requiring this semiconductor. This has happened over a period of time, and this is not something new. Earlier also semiconductors were being used. What has changed precisely in the last few years? Lopsided production. Is China heavily involved in this chain? So first of all, what's so special about semiconductors? Semiconductor, the whole industry, there were certain observations made by certain people which came out to be true, and this is why they're now today called as one is that the number of transistors will double. What is it called? Every few years. The Moore's law. There are two observations by people. What they said was, one was the Moore's law, which said that the number of transistors you can place on a semiconductor will double every year. And this has virtually happened. In fact, double se zyada speed pe they have increased. That means the technology will change at a very high pace. The amount of processing in a particular semiconductor can do, that will change very fast here. So we were doing in millimeters in 1960s. Now we are talking about nanometers. Nanometers also, the development has happened till highly specialized, the leading edge nodes, 4-5 nanometer, the chips that have been manufactured. And in this way, there are billions of transistors you can place. So the Apple chip, the A16 which they use, there are more than 14 billion transistors on a single chip. It's a very high performing phone. So the number of activities which you do on a phone, opening up a particular application, whether it is a camera, music, everything is controlled through a semiconductor, that A16 chip, which is manufactured by TSMC but designed by Apple. So what Moore's law said was that the cost of the technology is going to go down significantly, because the amount of functions which you will be able to do can be more, because the number of transistors will double. But consequently, another thing that was seen in this field was, and this was called as what he observed was that though you can place a number of transistors, but the cost of manufacturing a particular semiconductor chip is going to double every 4 years. The capital investment required for manufacturing of chips is going to increase every 4 years, or in fact it's going to double every 4 years. So on one hand, theoretically you can improve the sophistication of the chip. You can add number of transistors, you can perform number of functions, but the capital investment required to manufacture the chip, that will also increase multiple times. So on one end, the function of the semiconductor, you can perform multiple functions, but to manufacture that particular semiconductor, your cost is also going to go very high. These two laws, what it led to was breaking of the whole supply chain of the semiconductor. Do you understand what are global value chains? What are global value chains? And semiconductor was the first, one of the first global value chains that got formed. What do you understand by global value chains? Multiple backward and forward linkages. What is global and then what is value chain there? How? So the whole thing about global value chain, which takes the benefit of globalization is, so earlier globalization, the benefits of globalization was the country which has specialization in one particular product should only manufacture that product. Rest products, other countries which have a benefit or of manufacturing it, they should exchange. So for example, country A can manufacture a product X and has a specialization in it. Country B has a specialization in a product Y. A should not manufacture Y, B should not manufacture X. What they can do is they can trade. This was the early impetus of globalization, that you are going to have efficient use of resource, because A will not waste its resource in production of Y and B will not waste its resource on the production of X. So in order to use the resources efficiently which are less, you can trade. So the principle on which globalization was based on comparative advantage or specialization. That if you have a specialization in a particular product, you should only manufacture that product and not waste your resources on other products. Instead, get it from other countries which have a particular benefit in it. But as we saw improvements in information and communication technology, transportation and information could be exchanged easily, the whole product also could be manufactured at different places. So now if A has a benefit of producing X, since we have improvements in information and communication technology, the different parts of X can be produced in different geographies where you can find better efficiencies. So you don't, for example, if this country is producing this product, which is a mobile phone, information communication technology is improved so much that it is not necessary to produce the mobile phone at one place. Instead, what you can do is all of the parts of the mobile phone can be produced in different geographies to further improve the efficiency of resource. You can produce the chip semiconductor at one place, the body of the phone at one place. You can have battery being produced as a separate place, and you have assembly at a particular place. In fact, if you read in the news right now, India has mostly, what mobile exports have increased from India, have increased on the assembly front. We are doing the assembly of the parts which are manufactured at different places. This hyper specialization has broken down the whole value chain of the product across different geographies in order to have efficiency. This is not going to give you just productivity benefits. It is also going to have significant amount of cost benefits. So the country which has the maximum capacity or the ability to do so will be doing that particular part in a whole product. So a global value chain means that the value added in the product is spread across different geographies. This is what is meant by a global value chain, where the whole product is not being manufactured at one place. In fact, the value addition in this product is happening across different geographies. This is what is a global value chain. And how is it made possible? Because information can be shared easily. You can transfer electronically the information, and also the transportation has improved significantly. So you can have different parts being manufactured at different places, which can be then assembled at one place. This is what is the era of hyper specialization, where the whole product is not manufactured, but the value addition is being added across different geographies. And semiconductor was the first where this global, one of the first where this global value chain existed. Now, what exactly was the semiconductor global value chain? Is this clear? Now, the Moore's law for semiconductor says the sophistication of the chip will improve significantly throughout years. You can do multiple processes because number of transistors can be added easily. But at the same time, Rock's law says that though sophistication will improve, manufacturing cost will also improve. So you can design a chip but to manufacture that particular chip, the cost will increase significantly. So if the cost for the design company to manufacture it is also improving significantly, it is better to spread the whole value chain of the semiconductor across geographies where you can have the benefits both in terms of efficiency in use of resource and the savings in cost. Now, how did this semiconductor chain break down? These are the 4 major processes that happen in a semiconductor: design, manufacturing, the assembly, testing, packaging, and final distribution. The first process that happens here is the designing of the chips. And this is, see this, if you remember this value chain, you will understand the complete India Semiconductor Mission, because it is targeting each and every value chain of the whole product. Now, what exactly is with respect to the designing of the chip? The designing of the chip comes from the technology front. You have a particular chip where exactly you are going to have the transistors and where exactly what function will be performed. This is what is the designing of the chip. Designing of the chip, mostly this happens in, and some part also in, Europe. Now, based on the comparative advantage or specialization, certain countries are the ones which are dominating this value chain. US was the first one to have this dominance. In fact, Japan also had it, but Japan then lost most of its dominance to US. 1960s, 70s, there was some sort of war between US and Japan on semiconductors. And US, in fact, this war also was fueled by what was happening in the Cold War. So as a result of Cold War plus the conflict with Japan, US got its dominance. So most of the design companies of the world are US companies. Now, some of the US companies, for example, Apple, which is designing its own chip, but they are not manufacturing the same. They have given this contract for manufacturing to other companies, and this is where another country is the most significant, which is not China. 2 countries, in fact, are the world leaders here. Most of the market share is with Taiwan, and only one company, that is TSMC. The other one here is South Korea, the most famous company, Samsung. Samsung designs its own chips and also manufactures it. Samsung has both design and manufacturing capacity. The biggest 2 designing companies in US, one is Apple and the other is Qualcomm. The 3 biggest US companies here, the Apple, Qualcomm, and Intel. Intel also has IDM. Intel can also both design and manufacture. Intel and Samsung are 2 companies which are both in design and manufacturing, but mostly design companies are companies originating in US. So the most technical, sophisticated part in the whole semiconductor ecosystem, where 80% of the value lies, is the design part. How exactly the design will be formed. In fact, US has more monopoly in the designing system, because for designing, you also need certain tools which are called as the EDA tools. Now, what exactly are these EDA tools? The designing of the chip does not happen on a pen and a paper. There are special softwares which are called as electronic design automation tools. These tools are used for designing purpose. This also is a 100% monopoly of the US. Most of the US companies, Cadence and Siemens, all of them are electronic design automation. These are the tools which provide the software for designing a particular semiconductor. So designing and research, mostly US, the EDA tools which are required to perform that. For example, in mechanical, you would have heard of AutoCAD. What is AutoCAD used for? Mechanical designs, mostly it's a software performing that. Similarly, EDA is also a software, provides number of software to design a particular semiconductor. Another thing which is required for designing is your intellectual property companies. What are these IP companies? Now, there would be certain amount of designs which could be used as building blocks by companies to further improve their designs. For example, a particular company A had made a design of a semiconductor, placed certain things. Now, this design could be used as a building block to further have sophisticated designs made by other companies. This company will register an intellectual property right over its design. But this design can be used by other companies to make their own building blocks. This is what is the role of the IP companies. So in design, you have the US monopoly, which uses both IP and the EDA tools to perform this function. IP also has significant presence of UK and Europe. There's a famous UK company having significant IP that is called as ARM. So the first major function in semiconductor, why did we break down the whole value chain? Because we wanted efficiency, and secondly, we wanted cost benefits. Because both Moore's law says that you can sophisticatedly improve the design, but at the same time, you'll have capital cost. The second thing then comes is manufacturing. Manufacturing, this is what is called as a fab or a fabrication unit or a foundry. Manufacturing, so what happens in the case of Apple says, Apple has designed a particular chip, used the EDA or the IP companies, whatever they have designed a sophisticated, say A16 Bionic chip, they've sent the design to a manufacturing company which is going to deliver them the hardware. This manufacturing company mostly is TSMC. The monopoly mostly is of Taiwan, and there are some with South Korea also. Manufacturing this fab or foundry has a significant amount of capital investment. Roughly, capital investment in this is somewhere around $9 to $10 billion. This is the amount of capital investment required because there are significant amount of sophisticated tools used for manufacturing of these semiconductors. And this also has a significant life period, because if you are improving the performance of your chips, so for example, previously 60 nanometer chip or even 90 nanometer chip was functioning, now you have nanochips, 28 nanometers also being used in certain agencies, but jitni technology बढ़ रही है, they are coming to less than 10 nanometer. All of the three different specifications are going to require different capital investments and a different fab. This is why this field can become redundant very fast. Significant amount of manufacturing has to be done to get your capital investment back in an environment where the technology is changing too fast. There is a significant amount of capital investment. Along with this, it also requires significant amount of infrastructure quality. Electricity and water are the two components which are required in huge number here. This is why the environment cost of producing semiconductors was also high. One of the reasons why US shifted the manufacturing out of its own domain was the environmental cost which the manufacturing was taking. Not just the capital investment was huge, but the cost on environment was also huge. The infrastructure, both energy and water requirements. Plus, it has to be a clean environment because you're working on nanometers. A very speck of dust can destroy your whole fab. So, significant amount of state-of-the-art infrastructure is what you need in manufacturing. Then manufacturing requires two major things. One is the raw material supplies. Raw material supplies mein you have dominance of China. China has significant amount of production of silica, and the doping which is used, the number of rare earth metals which are there with China, this is its significant strength. This is the first strength which China has with respect to the raw material supply. Along with silica, number of rare earth. Now, why are they called rare earth? Not found, this is why. It's not about their availability. Availability is easy. It's very difficult to attract the metal from the ore. The difficulty in extraction is what gives them the name rare earth, but China has significant reserves and also has the ability to extract them commercially. China has that facilities. The equipment supplies required to perform this function of manufacturing. Now you have to perform something. Once you have the design, you have the manufacturing capacity. What is required here? A specific process of lithography. Light say you perform that function, and it is extreme UV lithography which has to be done, which etches the whole design of the semiconductor on the silicon at this specification. This is what is the use of the EUV in this particular technology. Now, what is special about this? Now, if you see, design is a monopoly of US. Manufacturing is mostly a monopoly of Taiwan and South Korea, and this is why the problem with semiconductor today. This raw material supplier is mostly a monopoly of China, and this equipment supplier, where the most important equipment is the EUV, the lithography here, this is done by only one company in the world. That is called as ASML. This company is of Netherlands. Only one company in the world manufactures this EUV lithography used for designing the high-end semiconductor chips, that is of Netherlands. And the lenses, again, is everywhere there's a monopoly here. And the lenses which are used for this lithography, the lenses are the monopoly of a German company, Zeiss Lenses. This is the alone company which can manufacture the lenses used for this lithography. Again, this machine can be manufactured only by Netherlands. This machine ko le jaane ke liye you need 5 airplanes. Such is the sophistication used in this. In fact, this company also came at a geopolitical conflict. So you have design, you have manufacturing, and then finally you have assembling, testing, and packaging. This is the end. Testing, packaging, and also assembly, where you require some amount of labor. It is both capital intensive and labor intensive, which has some employment potential. And right now, which India has signed MOU, four or I think 5 companies have signed for assembly, testing, and packaging. A name you would have heard in the news, Micron Technologies. Micron Technologies is a leader in assembly, testing, and packaging. It's a US company again. So you have 3 major supply chains. One is of design, which requires IP and EDA. You have manufacturing, requiring both tools and supplies, the raw material. Assembly, testing, packaging, the final end of the supply chain. Here also, assembly, testing, packaging. Here you have dominance of, any idea? Which countries? Here you require the least amount of, highest technology is here, highest capital is here. Assembly, testing, packaging only requires some amount of labor, cheap labor, and not very high skilled. So which countries could be the leaders in assembly, testing, packaging? India doesn't. India has absolute zero presence here. Commercial India does not do anything. Semiconductor Corporation Limited, ये चंडीगढ़ में इसका एक छोटा प्लांट है जो इसरो को चिप्स देता है. This is the only, and it's a very small level. India does not have commercial presence in any of this. This is why the semiconductor mission. If you would have been significant here, we would not require that. Yes, it's mostly the East Asian nations. Singapore has significant amount of ATP and another. Malaysia. So manufacturing, raw material is China. Supplies, or equipment supplies, there's one major player. It started with Japan, but now is mostly with Netherlands, Europe, and Germany. US or UK and EU are significant here. Design is all US. IP is also US, EDA is also US. So maximum technology is US. Now what happened to this semiconductor ecosystem in the last 5 to 10 years? First, the criticality of the technology is increasing because you have mostly digital applications which are now increasing. In fact, if you see what has happened recently in Lebanon, it's again related to what you can do with the critical technology. Pagers use हो रहे हैं, but फिर भी वो हुआ control semiconductor से ही है. So you can see the criticality of the technology. So first, the technology is improving significantly. Most of the technology would require a semiconductor. Now what happened with this semiconductor in the last few years? Especially with COVID or before COVID. So first reason for the increasing salience of semiconductors is the level of technology improvement. This is one of the reasons why now we have semiconductors, where all the countries are running after semiconductors, not just India. The second reason is geopolitical. And this was started with US believes that China is the threat, and this started with Donald Trump. Donald Trump says that not Russia, but China is the threat, because not only they are world leaders in low-end manufacturing, but they are also catching up to the higher-end technology. They are trying to develop everything. Few companies with China, such as and even one more. In fact, he was the one who initiated the strategic concern with Huawei. He was the one who tried to push Huawei from most of the Western countries which were allies of US, because all of these are gaining significantly in semiconductor supply chain, where they're trying to learn the design and the EDA tools. And most of the companies of US companies are complaining that the Chinese companies are stealing their intellectual property. There's a very big conflict between Cisco and Huawei, that Huawei has stolen mostly what the US has done. So US-China trade war starts, and US starts a number of export controls on China, where US companies are barred from sharing any higher technology products to China. This is the start of and this is how it is related to semiconductor, that US believes that China is going to beat them in this semiconductor chain, and semiconductor is something which is required in almost everything now. Not just the basic commercial technologies, but also advanced defense technologies. In fact, this was seen in the Russia-Ukraine war also, because Russia does not have significant supply of semiconductors. After the embargo placed by US on Russia, the previously used semiconductors are being seen in missiles used by Russia, because they don't have access to the newer advanced technologies. Now they could access it through China, but US has also imposed significant export controls on China. US has not just imposed it significantly on their own companies, US also influenced ASML to stop sending in the manufacturing tools to China to manufacture semiconductors, and it was highly successful in doing so. ASML stopped doing business with China. So the whole US-China trade war was hinged on the technological supremacy based on semiconductors. It further got complicated when you had the economics involved. The economics involved in this process, we said, the global value chain got emerged, and every country was doing where they were good at it. Now what changed here in this was, the whole benefit of global value chain was that the resource will be used efficiently, and also we are going to have cost benefits. But what it failed to encounter was that we do not have resilience to this supply chain. That means if one of the suppliers cannot provide it, I will not be able to get it from some other supplier. Since few monopolies existed, I could not shift from one supplier to another. That means during COVID-19, there was significant amount of supply shortages. In fact, in India, we could see that there was a delay period for normal cars which lasted 6 months, 9 months, 1 year, because they could not get even the trailing edge nodes. 28 nanometer, 45 nanometer was not being produced. Why? Because even if you see from the perspective of the manufacturer, he is getting more money for a lesser nanometer. 10 nanometers, 5 nanometers, 4 nanometers, he's getting more money. They stopped manufacturing the trailing edge nodes. Most of the trailing edge nodes, 45, 28, 60, 90, they are used in commercial technologies. So India could not get significant amount of semiconductors because they stopped doing it. Why? Because there was no other supplier who could provide the same product. So all of these combined, now countries are trying to build their own semiconductor capabilities. In fact, what happened during COVID-19 and what was fueled by US-China trade war was that there's a constant threat which Taiwan faces from China. That any day that China could invade Taiwan because it wants to learn whatever Taiwan has in terms of the manufacturing of semiconductors. And US, on the other hand, wants to support Taiwan. So what US did after COVID-19, they passed an act called the CHIPS Act. And this is where TSMC, the biggest manufacturer of semiconductor chips, has now agreed to operate a plant for manufacturing in US, in Arizona. And you can see what exactly the geopolitical significance of semiconductor is. TSMC, what will produce in US, is going to come at a cost which is 60% more than their own cost of production in Taiwan. But still they want to do it because of this. Because Taiwan is wary of what China can do. China wants to go up the supply chain, wants to cover the whole chain, design, manufacturing, and assembly, testing, packaging. They already have supremacy in assembly, testing, packaging. What they want is the design. Now, design requires intellectual property, requires a lot of technology, which they don't have. They want to capture both the design and the manufacturing. This is why the threat over Taiwan. Taiwan is definitely then going for US. Now, in fact, Samsung also wants to take the benefits under the CHIPS Act. Samsung has also committed a plant for manufacturing semiconductors in US. So US is also wants this resilience, reduce its dependence on China or countries which are under the influence of China. And how it could impact, we have seen in significant technology, especially in the Russia-Ukraine war. The whole reason Ukraine could stop the attack from Russia was the technological benefits given from US. And Russia is now reeling under pressure. This is why we see the closeness between Russia and China. It's all based on technology, especially the defense equipment, what comes in. So these recent changes as what has brought in the whole clamor about this technology, that is semiconductors. So you have three things here. Coming back again, you have design, manufacturing, and assembly, testing and packaging. And this is where India in 2021 announced its semiconductor mission. Semiconductor mission comprises of 4 different schemes. What the major features of the scheme, and each and every part is covered separately. First, that this is a dedicated mission which has a separate administrative agency which is called as the Indian Semiconductor Mission. This is the administrative agency which will cover the whole domain of the semiconductor mission. So there's a special bureaucracy with which you have to deal with, not the regular ministry or the departments, in order to get approval for any of the schemes under the mission. So a separate India Semiconductor Mission, which is an administrative agency, has been created. This is a mission which the government wants to operate for, giving them money to the tune of $10 billion. 2021, this roughly came out to be around 76,000 crore. And this money, recently they have promised to increase it to 15 billion. The Indian government is heavily spending on semiconductors because the whole technology of electronics is going to come from semiconductors. Now what they have done it through 4 different schemes. The companies can apply under different. The first is for design, which is called as the design linked incentive scheme. Now this is the only place under the design linked incentive where India has certain benefits. Why? Because though design is a monopoly of US, 20% of the engineers, of the design engineers in India or of world are Indian. But problem is, they do not work for domestic companies, they're all working for MNCs. So for example, Fairchild Semiconductors, or you have Freescale, or you have Texas Instruments, all of them are companies which are US companies. They have offices in US. So most of these design engineers, that means we have a significant amount of talent pool, but most of these engineers are working for companies which are multinational companies, mostly US companies. This is the only step where India has some advantage because we have significant amount of electronics engineers, we have significant trade pool. So what the government has done here is, under the design linked incentive scheme, the government first is going to provide all the necessary design infrastructure. Now, I told you for design you need 2 things. One, you need the building blocks which are protected under intellectual property. So under design infrastructure, you are going to get intellectual property prototypes, plus the government is going to buy the license for you. Along with this, the ETA, the automation tools, is also going to be provided by the government. All of this design infrastructure is going to come from, is going to be housed in one company, a centrally controlled PSU, that is CDAC. CDAC is going to help you with the design infrastructure for different design companies. Further under design, we have product linked incentive, where the government is going to provide maximum 15 crore rupees, provided You display to the government that you have certain design which you can build, that is, there is a product which you can have. So based on your own capability, the government is going to help you to the tune of maximum 15 crore rupees. Further, if you're already an existing design company, if your designs are being used in particular manufacturing, have been manufactured and been used in final manufactured in a particular commercial appliance, if you show them, the government is also going to help you on that. This is what they call as the deployment linked incentive. So on three ends, the design linked incentive scheme is going to help providing the design infrastructure. Product linked incentive, we're going to show them a particular design of the product. And if your product is deployed in a particular appliance, you can still get a benefit from the government. So these are the three things which the government has promoted under the design linked incentive. What the government plans to do here is, and what is a positive thing here, first, the government does not plan it to give it to only one or two companies. The government, since sees that India has significant amount of talent pool here, the government is going to support 100 companies under the design linked incentives. In fact, this is where we have certain benefits, but if we see the implementation part, this is the part which is lacking. So it's not just to one or two companies which are going to enjoy monopoly. The government wants to build 100 companies here. What are the eligible companies here? Eligible companies, and this is what is the biggest problem of this scheme. The eligible company is a domestic company, including an MSME, and also will be available to startups. But the problem here is, this domestic company which is eligible, the maximum FDI it can take is 50%. That means the controlling stake should be India. Controlling stake cannot be foreign. So you cannot have a multinational company operating which can take the benefit. It can be a Indian company. So mostly why we are planning semiconductor mission, because we want to enjoy some amount of self-reliance in this particular field. This is what is with respect to the design linked incentive. You will have the design infrastructure, product linked and deployment linked incentives, but eligible only are domestic companies, which includes MSME and startups. These are the things which are probable question for prelims. This is for design.
Completing the syllabus without proper knowledge of current affairs will not take you far in the UPSC Civil Services examination. Regulate and transform your preparation with complete coverage of news of relevance. Get a concrete hold of current affairs for UPSC CSE with Vision IS Monthly Current Affairs Revision Program starting from 20th September at 5 p.m. The program is your guide to get comprehensive news on one platform sourced through relevant resources such as The Hindu, Indian Express, Economic Times, PIB, Yojana and others. Enroll for complete coverage of current affairs including Indian polity and constitution, economy, international relations, and more. Comprehensive assessment of preparation through MCQs and mains-oriented questions. Expert support through personalized mentoring and online doubt resolution.
Can 100 companies. So what the government says in the policy is that there could be, are planning to promote 100 companies to come up and apply for this. Right now, no one has come for an application for this. तो हम कह रहे हैं कि 100 लोग तक भी हम support कर देंगे. We want to have multiple players in this, but should be Indian. And they have also placed a limitation here. Domestic company cannot take FDI more than 50%, and they have to remain domestic for at least 3 years. It's not that you take the money from the government and then take more FDI. You have to remain domestic till 3 years. So controlling stake of the Indian company should be retained till 3 years. This is how they are promoting self-reliance, or what is called as the Atmanirbhar Bharat. This is why it was part of the Atmanirbhar Bharat plan. We want some amount of self-reliance. Right now, India does not have anywhere in the global value chain of semiconductors. Everything is imported. In fact, why would we import chips? Because we are importing mostly the end products. If you see most of the products which are being used, we don't have chips being imported, we are importing the final product itself. Is this clear? How we are covered on design? Then the second is manufacturing. How are we covered on manufacturing? Manufacturing, India has no capacity for manufacturing, and this is where the scheme was modified also. Earlier manufacturing, based on the different trailing nodes, for example, if you have less than 28 nanometers, if you are manufacturing, you are establishing a plant for manufacturing semiconductors less than 28 nanometers, the government would give you 50% of your capital cost upfront. And as you increase the size, 28 nanometers to say 45 nanometers, it came down to 40%. 45 to 60, it came down to 30. But the modified version of the scheme now says, irrespective of the size, the government is going to give 50% upfront for manufacturing or having a fab capacity for manufacturing of semiconductors. So if anyone establishes a fabrication unit or a foundry, so the first was for only design. The second is for setting up the manufacturing capacity or the fab. 50% of the upfront cost of the plant will be given by the government. The benefit here are two things. One, there's no reimbursement, that you don't have to invest first hand, the government is going to give 50%. And the second benefit here is, India right now cannot have the capacity to manufacture 4 nanometers or 5 nanometers. As we said, as we grow better in technology, the cost for manufacturing it also increases significantly. 28 to 45 still has a significant life cycle because cars and other appliances are still going to use 28 nanometers. So even if we are not getting the leading edge technology, we are still working on technology which will be relevant for the next 5, 10 or 15 years. So this shows there is a sustainable approach of the government. Previously the government says better the technology, more the benefits. But now the government is saying throughout we are going to give the same benefit. This will be given only to two fabrication companies. And this was the recent MOU signed. Any idea which company has signed with what? Yes. One of them has been signed by, I think in Dholera, they have said that they're going to establish a manufacturing plant. Tata, in combination with another company, has applied for this. There's only one right now, fabrication unit. 4 other MOUs have been signed. I think 3 in Gujarat, 1 in Assam. All of them are assembly testing and packaging. 1 for manufacturing of fab and the rest are assembly testing, manufacturing. Then the third part of the scheme, apart from manufacturing, is the assembly testing, packaging. The assembly testing packaging, this scheme has 2 specific features. One, it targets something called as compound semiconductors. They are used in specific devices, mostly display devices. There's something called as silicon photonics, I think. Compound semiconductors is one separate part of the scheme, and the other is for specially assembly testing and packaging. Where you don't have the manufacturing or design, you import it, and the imported is tested and packaged here in India. For this, the government plans to have 15 companies, for which again the government is going to give 50% of the capital investment. This is where you need a certain amount of, this is where you'll create certain jobs. And a very unrelated thing has also been included in the semiconductor mission. So there are 4. One is for design, the other is for manufacturing. Assembly, testing, packaging, one for compound semiconductors and the other for assembly. Both of them have the same 50% capital investment. Earlier it was 30%. Last year the government changed it to 50. Then you have, this is something which is not related to semiconductor, but the government has included this here itself, the display technology. Now, why this has been done in India, display technology? Because these are your display technologies. The AMOLED being used in mobile phones. 25% of the mobile phone cost comes from this, and the LCD LED, 50% of the cost comes from this technology. And India again does not have any presence here. All of this is presence of, mostly you'll see OnePlus and all Chinese companies selling LCD and LEDs. You have in fact, the global leader for display technology is South Korea. Samsung OLED, QLED, OLED came from LG, both of them companies from South Korea. Now, this is difficult to explain why the government is spending on display technology, because this product did not face any consequences in semiconductor. In the COVID-19 phase, where you saw any supply shortages. There was no supply shortages of the display technology. So this is not specifically related, and there's not a lot of logic behind why the government came out with this. Because if you see that the logic which the government gave for introducing this scheme for display technology was that we have to reduce the China dependence. Now, why this logic does not work is, first, even if you are not taking from China, you had other global leaders where you enjoy a good relationship. And if you see, China is not on the leading edge is still South Korea and Japan. Secondly, even if you depend on South Korea and Japan and you're trying to end for the final product the dominance of China, the raw material still is coming from China. So a lot of supply materials are still going to come from China, even if you're not taking the final product from China. So the raw material dependence is not going to end anytime soon. First, there was no supply shortage. Even if you want to end the dependence on China, you still have South Korea and Japan. Plus, raw material is still going to come from China. So this scheme is slightly difficult to explain why did the government go with this, but still we are going with the display technology also. And finally, what is the most surprising thing out of all this is that the government is giving benefit only for production of AMOLED and LCD. The government does not cover the higher end technology. The higher end technology, the QLED or the OLED, is not being covered under this scheme. So the government benefits for display technology are only for mobile phone, the AMOLED, and for television, that is the LCD screens. These are the 4 large schemes in the Indian Semiconductor Mission. This is what the government is going to target through a separate administrative agency, which is the Indian Semiconductor Mission. Is this clear? Now, what could be the challenges behind this? We have not seen a significant amount of interest shown by a number of global players to establish facilities in India. What could be the problem? Just discuss in brief the concerns. Skilled labor. Design requires the maximum skill, and India has the maximum skill required. Electronics engineer बहुत है India के पास. What could be the concerns related to the semiconductor mission? One, in manufacturing, the biggest problem is the technological improvement is quite significant. We need to catch up with this. We can't just stick to the 28 nanometers or 45 nanometers. We have to improve where the world is going. And both artificial intelligence will be better if we have smaller chips with more transistors. So first is you need to catch up with the technological improvements that is happening over the world. The second thing is manufacturing is highly capital intensive and requires significant amount of infrastructure. Do we have the capacity to provide that quality infrastructure, and what about its environmental cost? The major reason for US shifting out of the manufacturing plant out of US was the environmental cost. They could still bear the manufacturing cost, but the environmental damage that was happening because of this was quite high. So this is one of the concerns in manufacturing. Other concerns in manufacturing is IP still you can get because technological improvement, capital intensive. India is in need of this, not this. Most of our manufacturing is capital intensive. There is absolutely no scope for job creation. What could be the other problem in manufacturing? That is in fact said to be the biggest problem with India. Tariffs. The biggest problem is all of your manufacturing is going to ask for a significant amount of imports. Both of them require connectedness with the world. You cannot have tariff barriers. Because the moment you impose tariff barriers, you're not going to get this, and whatever products you need as imports, like we discussed, the global value chain is distributed. If you have tariff barriers, trade barriers, manufacturing plant will be almost impossible to set. So if you impose certain conditions on the goods coming from China, you'll not be able to manufacture semiconductor because China plays a significant role in the raw materials that come for manufacturing of this. The tools are coming from Japan, Netherlands, and mostly Europe. But raw material for manufacturing semiconductor is still coming from China. You can't have tariff barriers. This is one of the biggest problems. Then there are concerns associated with assembly testing packaging also. What could be the concern there? Now, assembly testing packaging also can be costly in India. Why? Because assembly testing packaging, if the chip is not being manufactured, one, you will have to have a cost when the chip comes in India only for this purpose. And secondly, even if it is not used for using it in the final equipment, the original equipment is not using the semiconductor. This is not in India, this is not in India. So the transportation plus tariff barrier is going to increase the amount of, or increase the cost for assembly testing packaging in India. Because if you see, the backward and the forward chain both are not present in India. More cost benefits will be produced if we have certain amount of manufacturing. Another thing which is now emerging as a problem with the assembly testing packaging, even with China and other countries, for specifically Malaysia, that there is a significant amount of technology improvement in assembly testing packaging also, where they've used certain 3D packaging techniques which is still present with only few players. So even the field which was, or even the value addition part which was seen having the least amount of technology is also improving on technology. So 3D packaging is seen as the next frontier which only few companies are practicing. So if India starts establishing this, it needs better technology and also needs better linkage. And if you do not have infrastructural connects and you have trade barriers, you're going to have a problem. Finally, the problem in design. We have seen 4 MOUs signed in assembly testing packaging, and we have seen 1 MOU for manufacturing. But we have not seen a significant amount of interest where we have the benefit that is in design. Why not here? Why the design companies are not starting in India? In fact, this is where India has some comparative advantage as compared to other countries. Rest of the places you see manufacturing and assembly. Assembly testing packaging also we have advantage of cheap and low skilled labor. The problem is, the design company has an eligibility criteria often. That means you have a limit of how much FDI you can take, that is 50%. Even the design company, to give you certain benefits, will have certain time period. You'll not get on the first day itself that the design company is going to give you certain benefits. Now, if the FDI is limited to 50%, the support which the government gives should also be substantial, then only particular Indian company will apply for this. But the support, if you see, maximum in product linked design is coming as 15 crores. 30 to 40 crores, I think, is maximum in deployment linked incentive. So the amount which you are giving for support is less, and you are not allowing FDI. So the capital required for the Indian company to start a design itself is very less. This is why we are not seeing a lot of interest in a particular scheme which has a lot of potential. Which has a potential for improvement, because the support otherwise coming from EDA tools and IP is significant. If we are trying to fight this, if we try to break this limit, it will be beneficial. This is what is the overall problem with this scheme. The overall scheme says that India wants to achieve self-reliance. That means India wants to reduce the level of import. But what we have seen in the complete semiconductor supply chain is that it will always be import intensive, not just in terms of material, but also in terms of technology. This is the underlying problem with this scheme, that India is trying to achieve self-reliance in a particular field which is heavily embedded in global value chains. So until and unless the support provided is significantly huge, even if we provide significant support, still it is linked throughout. In fact, if you see the raw materials, there are certain critical raw materials that also came from Russia and Ukraine. It's easy to find other suppliers for that, but still those two countries were also embedded in the semiconductor supply chain. And in that, if you're trying to impose trade barriers, this is going to become a very big problem. Because other than trade barriers, you're not going to achieve any self-reliance. This is the larger problem. So you have 4 things across the spectrum. First is design linked incentive, manufacturing 2 fabs, 15 assembly testing packaging along with compound semiconductors, and finally not related to it but display technology. And these are the issues that are with the semiconductor, the whole mission. Indian Semiconductor Mission is an administrative agency so that they do not face any bureaucratic hurdles. Is this clear? Any doubts in this? What? Yeah, this is expected to play a role because we are expecting this technology to come from US. How else do you expect to learn from someone else? ICT, plus there's one more thing. There's a initiative of Code on Semiconductors. This is also quite significant, and this is what can help India here. There's all the 4 Quad countries are also now combining for the semiconductor mission. So there's a vertical under the Quad for promoting semiconductor information exchange throughout these countries. If you see the whole perspective of semiconductors and why India is also now participating in it, started with the anxiety which US had with respect to China. The anxiety got certain evidence in COVID. So everything materialized. Because US always had that technological anxiety that China might go ahead. All of these developments, whatever have happened in semiconductors, have happened because of this only. So US was beaten by Russia, USSR when Sputnik happened. Japan started beating them. Japan had a special program called the VLSI program where they started building commercial semiconductors much at a faster speed than what US was doing. So that technological anxiety is what led US build all of its supremacy. Semiconductor supply chain built up for having cost benefits. But again, when now US is being threatened by China's supremacy in this field, though China is still far away because China does not have the design capacity, but still US wants to take a lead. India also thinks that we are dependent on China where we do not have very good relations. This is why we should also decouple from China and develop certain semiconductor capacity of our own. There were different programs channeling on different semiconductor supply chain, but anything could not materialize because of the interference of the government. The bureaucratic red tape was quite high. This is why this program, the 3 features, 1, a separate administrative agency, a program for 10 to 20 years, and more than $10 billion which the government is committing, most of it upfront. Why? Because we want to build some of the capacity in our own country. This is what is the significance of the semiconductor mission. Is this clear? Any doubts here? The next topic is, do we have time? We'll have another session for middle income trap. We'll combine with some other topic. Middle income trap we'll do with some other. Thank you.